decay equations. All right, so here is our class notes and our practice sheet. We have alpha decay and we have beta decay. During alpha decay, an alpha particle is released from the nucleus. An alpha particle is a helium-4 particle. There it is in isotope notation. Here it is in atomic notation. In atomic notation, the number on the top is the mass number, which is 4 in this case. The bottom number is the atomic number, which is 2 in this case. Now, here's an example of an alpha decay equation. This is gold 185, so Au-185 is the isotope. Gold 185 alpha decays into iridium 181 and a helium-4 particle. We know this to be true because the mass number of gold is 185, the mass number of iridium is 181, and the mass number of helium is 4. Look at this up here. 185 is equal to 181 plus 4. This, knowing that that's how this works, will help you with our Canvas quizzes because there will be times when I don't give you this number. You would need to figure out that number by going, 185 minus 4 gives me 181. Or I might give you 184 and 4, and then you have to come up with 181 plus 4 is 185. And so on and so forth. I will do that with the mass numbers. I will also do that with the atomic numbers down here. Check this out. Gold is atomic number 79. Iridium is atomic number 77. Helium is atomic number 2. 77 plus 2 equals 79. So that is alpha decay. Now, what is actually going on in the nucleus is that the nucleus loses 2 protons and 2 neutrons. It loses 2 and 2, which gives us 4, which is why this is a helium-4 particle. Now, for practice, what I want you to do is take a look at these elements here, and then we're going to go to our periodic table and figure out what they would decay into. Sn is tin. It's going to lose 2 protons. So let's take a look at tin, which is Sn right here. It loses 2 protons. So we go from 50 to 49 to 48. So minus 2. So it becomes cadmium, which is element number 48. So then right here, I'm going to write CD as my answer for what tin would decay into. What I want you to do at this point is to pause the video and figure out each of these and what they would be. Pause the video to come up with what would chlorine be. Find chlorine on the periodic table, subtract 2, give me the name of the element right here. When you are done doing that, then unpause the video and look at the answers. Pause now. Welcome back. There are the answers. All right. By the way, I also meant to throw this in there. The daughter product, by definition, is the result of radioactive decay. So if right here, LV, that is the parent material. It's the thing we start with. Parent material. If it goes through radioactive decay, what it becomes is the daughter product, which is FL in this case. Okay, so and to clarify, that is a cursive L, so FL. All right, beta decay. During beta decay, a beta particle is lost. A beta particle is just an electron. It has no mass number because it has no protons and no neutrons. It has an atomic number of -1. I do not remember, guys, right now why I wrote minus a -1. Oh, I do know. Because for the way this one works out, with what is actually happening in the nucleus, is one of the neutrons is breaking down into a proton that goes away. And it's from a neutron, is breaking down into a proton and an electron. The electron stays in the atom. Now, it does not stay in the nucleus. It joins the electron cloud. I completely take that back. It completely leaves the nucleus. I think it completely leaves the atom, but what that does is irrelevant. one of the neutrons breaks down into a proton. That means in the case of beta decay, we are going to add one more proton than there was before. If we are losing a -1, minus a -1 actually gives us a +1, okay? So in the case of beta decay, you would add one more than it was before. For instance, bromine 82 turns into krypton 82. The mass number did not change because 82 goes to 82 plus 0, which is still 82. But what happened is the atomic number, it was 35. It goes up by 1 to 36. And 35 plus 36 minus a -1 is also 35. I will write that one out. 35 is equal to 36 minus a -1. How did that work out? Oh, because it is 36, not minus, it's plus a -1. 36 plus -1 is 35. So now this time what you're going to do is, for your practice, you're going to look for carbon on the periodic table. We're going to increase by 1 proton and see what we get. Here is carbon. Increasing by 1 proton gives us number 7, nitrogen. So the answer here is nitrogen. I want you to pause the video now, figure out the rest of these elements, then play the video and look at the answers. So pause now. And there are your answers. And that's how you do alpha and beta decay equations. Use these notes and this video as needed moving forward to do your quizzes.